We're on episode 74. If you're not on YouTube, you can go to PATRIOT'S and look under the shows tab for big tech, and you'll get the notes there. Twitter, Human Internet One, and Parlor, Human Internet. And the website that I'm working on is humaninternet.org. If you notice a theme there. Today, we are going to look at some initiatives from the White House and from Congress related to AI and quantum. We're going to watch a video from the founder of Dwave, a guy by the name of Jordi, and you can decide for yourselves what to think when we're done. But the bottom line is we're moving into territory that is similar to sailing across the ocean for the first time or going into space for the first time, that kind of a thing. And they know it. And I think what we're going to look at today is really just demonstrative of the White House taking some strong stances in order to ensure that the United States maintains its position technologically and economically, for that matter. So, episode 74, and we're going to look at AI and quantum tonight, just at a very high level. I pulled a lot of the information from my Twitter likes feed, and they're all here, all the raw information, national laboratories, announcements from the White House, couple press releases, and it's intermixed amongst some other things that I've liked. But I've pulled some of the stuff out so that we can look at it. And so we'll start. The White House announces a $1 billion investment for AI quantum computing hubs. And what this basically is getting at is they are throwing a lot of money at quantum computing, AI development, and the fusion of those things, because they are going to transform the way research and development and just basically everything on an industrial scale is going to be impacted by the implementation and application of quantum computing and AI. $1 billion investment into two of tech's most promising frontiers, AI and quantum computing. Last month, Trump administration rolled out an executive order on AI, declaring its intention to bolster U.S. dominance in the field. But the order didn't address much in the way of funding its plans. This February, the Trump administration called for more than $2 billion to be invested in non-defense AI and quantum research by 2022. Non-defense AI, which means that there is more money going into defense AI. So we will continue. The White House announces a $1 billion plan to create AI quantum institutes. Effort aims to keep the U.S. globally competitive in artificial intelligence, quantum technologies. White House on Wednesday. So just take note of this date here, August 26th. This was literally just a few days ago. The White House on Wednesday will announce that federal agencies and their private sector partners are committing to more than $1 billion over the next 5 years to establish 12 new research institutes focused on artificial intelligence and quantum information science. The effort is designed to ensure the U.S. remains globally competitive in AI and quantum technologies, administration officials said. National Science Foundation and other federal agencies, including the U.S. Department of Agriculture, will invest $140 million in 7 institutes focused on AI, while the Energy Department will supervise and invest $625 million in the 5 institutes focused on quantum information sciences, which includes quantum computing, quantum information sciences, and a piece of that is only quantum computing, right? So there's a whole lot more going on in this quantum space beyond just a quantum computer. The Department of Energy's investment will be matched by $300 million in private contributions, part of which comes in the form of technology services donations from IBM, Microsoft, and other companies. Wonder what that's going to look like long term. This is a sharing of technology, right? So taxpayer money fused in with corporate money. They're going to jointly embark on this endeavor. So just keep that in mind. The news comes on the heels of the Trump administration's proposal to spend about 30% more in the 2021 non-defense budget for artificial intelligence and quantum information science. It also coincides with competitive pressure from China and other countries that are investing in these emerging technologies. China is adopting AI at a faster rate than the US and the European Union, according to a 2019 report released by the Center for Data Innovation, a nonpartisan research institute. It's absolutely imperative the United States continues to lead the world in AI and quantum, said U.S. Chief Technology Officer Michael Christosis. I think that's how you say his name. The future of American economic prosperity and national security will be shaped by how we invest, research, develop, and deploy these cutting-edge technologies today. The AI institutes will research how technologies can be used in areas such as precision agriculture, weather forecasting, and more. The institutes will be hosted by universities across the country: University of Oklahoma, University of Texas at Austin, University of Colorado, University of Illinois at Urbana-Champaign, University of California, Davis, and Massachusetts Institute of Technology. Quantum institutes will focus on areas including quantum computing and networking. The work will be hosted at the Energy Department's Argonne, Brookhaven, Fermilab, Oak Ridge, and Lawrence Berkeley National Laboratories. So there's multiple facets going on here, folks. AI research into technology. It's going to improve how humans basically interact in their world, from agriculture to weather forecasting, likely in material sciences, construction, medicine, all of those things, as well as quantum networking, which has to do with building a quantum internet. Among the Institute's objectives is to conduct early research in areas the private sector is less likely to invest in, but which the administration considers important for the nation's competitive position. For instance, one of the AI institutes will work on developing AI-enabled tools that can advance the discovery and manufacturing of new bioactive compounds. The institutes will also serve as a training ground for the next generation of experts in AI, and the White House sees them as a way to promote diversity in the sector. At least 6 minority-serving institutions, including historically Black colleges and universities like Tuskegee University, are among the partners, said the National Science Foundation Director, Sethuram Panathan. Interesting. In this way, we are establishing a network that we hope expands to involve not only every state, but every segment of our society. Taxpayer-funded investments are already part of the budgets of participating federal agencies, a White House spokeswoman said. So let's continue down the rabbit hole here. August 26th, the Trump administration is investing $1 billion in research institutes to advance industries of the future. Trump administration is taking strong action to ensure American leadership in the industries of the future: artificial intelligence, which is AI, quantum information science, 5G communications, and other emerging technologies that will shape our economy and our security for years to come. Today, the White House, the National Science Foundation, and the Department of Energy announced more than $1 billion in awards for the establishment of 12 new AI, quantum information science, research and development institutes nationwide. Notice that 5G's in there, folks. There's more to 5G than a 2-second 4K download, and I'll show you that momentarily. Together, National Science Foundation's AI Research Institutes and the DOE's Quantum Information Science Research Centers will serve as national R&D hubs for these critical industries of the future, spurring innovation, supporting regional economic growth, training our next generation workforce. So on and on and on. The news articles we read summarize this White House publication. Large-scale quantum cryptographic key distribution network from Verizon. Verizon, one of many major telecoms. I've looked around for other telecom patents that are similar to this, have not found them. I found some other interesting quantum patents in Boeing, for example, has some. And Nokia has some. Banks, Bank of America, Wells Fargo, they've got quantum patents. They're most interested in this type of security for the business that they're in. But what I want to share with you is this idea of the undergoing or the current endeavor to create quantum internet connectivity. Quantum internet connectivity. Space-based satellite device obtains one or more encryption key symbols. This is quantum encryption. First step for a secure network, right? Privacy. The satellite device transmits the one or more encryption key symbols to multiple nodes of a land-based network using quantum cryptographic mechanisms. So you have satellites in the air communicating with land-based nodes on the ground that are all interconnected with each other. And you have a key management system that provides encryption in the air and through the fiber optic networks. So there's a lot going on here. When you look at quantum networks from the national laboratories and others, they talk about using fiber optics a lot. But they can send quantum information wirelessly. They can use lasers. They can use sound. They can use radio frequencies. They can basically use the electromagnetic spectrum, which is millimeter wave, radio wave, light, X-ray, gamma, all of it. They can use sound, and they can use glass, silicon, which is the fiber optics. And that's what people typically understand as, photons. When you hear photons, you think light. Hear photonics, right? You think light, you think fiber optic cables to transmit that stuff around. It doesn't stop there. They can encrypt using wireless transmission characteristics. And I'll show you that here briefly in this patent, and then we'll move forward. So I want to show you in this patent, they talk about using radio frequencies. The key management system may send key distribution instructions, for example, a radio frequency link to a satellite. Based on the instructions received from key management system, begin distributing encryption key symbols to selected ones on a network node through, for example, free space links. Free space links. That means not inside of an optic cable, not inside of a coax cable, twisted pair cable, power line, none of that. Free space, wireless transmission. Could be with a laser, could be with another piece of the electromagnetic spectrum like radio frequencies or millimeter waves, which is what's currently in use for satellite to satellite, satellite to ground-based communications. Satellite to satellite uses lasers as well, but they can create laser-like characteristics with microwaves, and that's called a maser, not a laser with an L, but a maser with an M, mic, M-A-S-E-R, maser. And what that is it sends microwaves, but they send coherent waves where all of the waves match up, so that they're very focused and very powerful. And they can do some very interesting things with masers. And as time goes on, when we start looking at wireless power distribution, which is going to, we'll discuss that shortly. Not sure when. I'm still working on trying to get my head wrapped around it. But wireless power distribution basically uses the same type of idea where you use coherent electromagnetic waves to literally transmit power through the air, so that you can wirelessly charge mobile devices, remote controls, gaming consoles, laptops, whatever you want. You can wirelessly charge them like 30 feet away. And there are patents for that and companies that are building that, and on and on and on. So let's keep looking for RF. So it says here, a satellite may include a processing unit, a memory unit, input device, output device, a free space quantum transmitter, an RF transceiver, and a bus. An RF transceiver may include any type of transceiver-like mechanism that enables satellites to send and receive RF signals to and from other devices. It could be another satellite, it could be a phone, it could be a cell tower, it could be a satellite dish, it could be an uplink or a downlink land-based system. A common satellite downlink would be a video head end, where they would record video, like a news center would record video and they would uplink it to a satellite, and then that satellite would bounce it around and it would downlink it to an office somewhere, a telecommunications office, where it would then go over the land-based network, and they can send information around the globe very, very quickly via satellite with uplink and downlink. And that's what they're talking about, is using radio frequency signals to basically transmit information over or up to, through, and down from a satellite network. It talks about being able to use an RF link with the LAN node, LAN networks, and having these links established with radio frequency. So pretty much the way satellites work now, only they're going to put quantum encryption over top of these transmissions. So what does that look like? How does that work? So basically, as a highlight here, details about key distillation or coding, reconciliation, error correction, privacy amplification, polarization, coding, or phase coding. And so when we start looking at polarization or phase coding, what it really discusses or describes is the certain ways or certain characteristics of a photon that as it's traveling through free space, and they can track these things, they can send them in very specific ways. And because they have a great deal of control over how they send photons through air or through a vacuum in space, they're able to actually use those characteristics to encrypt information, and they're able to do it on a quantum network. So it says here, free space quantum transmitters may include components for distributing encryption key symbols via a free space link using quantum cryptographic techniques. In one implementation, free space quantum transmitters may distribute encryption key symbols by encoding each encryption key symbol, encoding the encryption key symbol into the phase, polarization, or energy state of a transmitted photon. And when you think photon, you think light. That's fine. That's a correct answer. But photons also occur in the microwave, millimeter wave range, gamma wave range, X-ray wave, photons. A photon can have different amounts of energy in it based on the wavelength. The longer the wavelength, the lower the frequency, the less energy per photon something has. The higher the frequency, the shorter the wavelength, the more energy per photon it has. So what they're getting at here is that they can track and understand very precisely the energy state of a photon, the polarization of a photon, 0 degrees, 1 degree, 2 degrees, 3 degrees, all the way to 360, right? The polarization and the phase. And the phase has to do with when it's transmitted, also in 360 degrees. If you were to look at it on a graph, they can transmit it and offset the phase. And we'll get in more into that when we start looking at wave coherence and wave decoherence, because that has everything to do with being able to transmit power wirelessly. And that's beyond the scope. Just know that it's possible, it's reproducible, and it's very, very tangible, and you can track it and identify it to the extent that they're using it to encrypt information on a quantum network. It's basically it. And this is done wirelessly. A quantum modulator may modulate a state of each quantum particle emitted by a quantum source to encode each quantum particle with an encryption key symbol. One implementation, a quantum modulator can modulate the phase or the polarization and or the energy of an emitted photon. Critical, because this has everything to do with the construction of the 5G network. Very precise, beam-oriented, basically laser beams And I'm using that and being slightly dramatic. They're not exactly laser beams, but when compared to the older technologies, they are. You're able to control all of the aspects of how electromagnetic radiation is transmitted from each one of these beams or by each one of these beams. You can then begin to encrypt using the transmission link itself as an encryption mechanism, whereby if somebody intercepts or interrupts that link or taps into it wirelessly, if they're trying to intercept that wireless link to measure it and monitor it, it actually changes these things. And that's how they're able to tell if there's eavesdropping, and it corrupts the information. And that's another benefit to quantum encryption, is that if you try to observe or intercept a communication in a quantum network, you destroy the information. So let's move on. White House Office of Technology Policy, National Science Foundation, Department of Energy announced $1 billion in awards for artificial intelligence quantum information. This is from energy.gov. So this is a carte blanche rollout. All departments, off we go. We're going to go back in history just a touch. This is congress.gov, HR 6227, National Quantum Initiative Act. The last action of this act on December 21st, 2018, 12/21/2018, this became a public law. National Quantum Initiative Act 12/21/2018. And it talks about putting together all of these organizations, agencies, if you will, to start working on this collective problem. National Institute of Standards and Technology, quantum activities. National Science Foundation, quantum activities. Department of Energy, quantum activities. Advisory Committee means the National Quantum Initiative Advisory Committee established under Section 104A. The Committee on Commerce, Science, and Transportation of the Senate. Committee on Energy, Natural Resources of the Senate, Committee on Science, Space, and Technology of the House of Representatives. Coordination Office. They're going to establish a Quantum Coordination Office. Institutes of Higher Education, which is defined based on the Higher Education Act of 1965. Quantum information sciences, according to this law, means the use of the laws of quantum physics for storage, transmission, manipulation, computing, or measuring or measurement of information. That is what they are looking to learn more about, understand, master, be the best at. The laws of quantum physics as they relate or pertain to the storage, transmission, manipulation, computing, or measurement of information. Purpose: supporting research, development, demonstration, and application of quantum information science and technology to expand the number of researchers, educators, and students with training in quantum information science and technology, to develop a workforce pipeline. Multidisciplinary curriculum, research opportunities for quantum information science at the undergraduate, graduate, and postdoctoral level. This is good to see, because this needs to be deployed down to high school level, in my view. But this is, baby steps, as they say. Address basic research knowledge gaps, including computational research gaps. Promote further development of facilities and centers available for quantum information science. Stimulate research and promote more rapid development of quantum-based technologies. Maximize effectiveness of federal government's quantum information science and technology research, development, and demonstration programs. Federal laboratories, industries, and universities. Cooperation, collaboration amongst those groups. Promoting the development of international standards for quantum information science and technology security. Meet economic and national security goals. National Quantum Initiative. President acting through federal agencies, councils, working groups, subcommittees, and coordinations office as the president considers appropriate, shall establish the goals, priorities, and metrics for a 10-year plan to accelerate development of quantum information science and technology applications in the United States. Invest in fundamental federal quantum information science and technology research, development, and demonstration, and other activities to achieve the goals established under paragraph 1. Talks about the establishment of the coordination office, multidisciplinary center for quantum research, education established under section 302, national quantum information science research centers established under section 402, subcommittees. Membership of the subcommittees shall include representatives of the National Institute of Standards and Technology, National Science Foundation, Department of Energy, National Aeronautics and Space Administration, NASA, the Department of Defense, the Office of the Director of National Intelligence, Office of Management and Budget, Office of Science and Technology Policy, and such other federal department or agencies the president considers appropriate. All right, let's pause here. I see that, yeah, this is a lot of information to take in. This is not going to be the only 2-hour brick of time that we're going to talk about quantum. Please don't try to understand this in the short clips or bits that you're getting it. This is simply for just general absorption, general understanding at this point. Just understand that quantum networks can function on the same networks that exist today that move information around the internet. And the idea behind the federal mobilization to understand quantum information science goes hand in hand with AI. And it goes hand in hand with quantum computing. And all of these things are going to radically change the world as we understand it. That's the 40,000 foot view, so to speak. And it's enough of a deal, enough of a big deal, important enough, such that they are throwing billions of dollars at it in a very, very condensed period of time. And this is just the public budget, folks. This isn't the military budget. And as we move forward, you will see that this has been around for 2 decades already. So this rollout to the public, oh, look at this new thing, it's quantum, yay. I believe that we have been functioning, and I say we, I'm talking humans, have been using and functioning or using some functionality of a quantum network, quantum computation for decades at this point. So just understand that from a civilian's perspective, what we have access to on the public internet at this point, a lot of heavy hitters are assembling in these committees and subcommittees to collaborate and help steer, guide, and direct institutions, higher education, national laboratories, and industry to collectively deal with this problem because it has everything to do with economic and national security. I really want to show you this video from Jordi Rose. Let's see if there's anything else interesting in this. We could spend a whole show just looking at this law, quite frankly. So we may come back to this and just look at this law in some more detail. So we're going to continue on. This is in the show notes. This law is in the show notes. Public law. It gives subsets, sub-instructions, so to speak, or sub-directives for all of the major organizations, National Science Foundation. This other one up here was National Institute of Standards and Technology. They all have specific criteria that are lined out for what it is that their primary objective is. So with that, we'll move forward. We are, this was 2018, December 21, right? This is an executive order, basically 2 months later, 2019, February 11th, 2019, executive order maintaining American leadership in artificial intelligence. This goes hand in hand. Artificial intelligence promises to drive growth of the United States economy, enhance our economic and national security, and improve our quality of life. The United States is the world leader in AI research and development, R&D, and deployment. Continued American leadership in AI is of paramount importance to maintaining the economic and national security of the United States and to shaping the global evolution of AI in a manner consistent with our nation's values, policies, and priorities. Federal government plays an important role in facilitating AI R&D, promoting the trust of the American people in the development and deployment of AI-related technologies, training a workforce capable of using AI in their occupations, and protecting the American AI technology base from attempted acquisition by strategic competitors and adversarial nations. That, folks, is the main body of this, in my view, because whoever has AI and cyber supremacy is going to be able to take whatever they want from anybody else. They will literally be able to just log in and take it. And from what I understand with quantum, if you have the quantum supremacy, they won't even know you were there. Because they'll just take it and your quantum network will look as if nothing ever happened. Yeah. Chat, I see you out there. You starting to put some of the pieces together, huh? Do you know that the brain is a quantum computer? Do you know that when they start manipulating things at the quantum scale, they're dealing with atoms and electrons, protons and neutrons and quarks, that kind of stuff? That's kind of what we're made of. And when we look at quantum entanglement, if they can entangle objects at distances and they manipulate one of the entangled particles, then the other one has a known change that occurs when that manipulation takes place because the photons or the particles are entangled. So there's a lot that's going to go on when these quantum networks come online and they start integrating everybody onto the internet, literally integrating everybody on the internet, and we're going to parallel construct these quantum networks. And there are a plethora of ways at that point to potentially interact with each other or with AI interacting with us. And that's kind of more or less what I think people like Elon Musk see coming. Is once we break through that barrier, so to speak, of understanding biologic code and being able to convert it to digital code in real time, and you have AI running over these networks, managing these networks, go ahead and put two and two together, folks. And that's where national security, civil liberties, I see that in here. Maintaining American leadership in AI requires a concerted effort to promote the advancements in this technology and innovation while protecting American technology, economic and national security, civil liberties, privacy, and American values, and enhancing international and industry collaboration with foreign partners and allies. So what do civil liberties and privacy mean to you? What's it going to look like when we have these networks all around us? So just to show you, this is just what I found. Who knows how far back this really goes. Defense Science and Research and Technology, DARPA, Defense Science Office, solicitations. It's back in November 7th of 2003. DARPA, Defense Science Office, purpose is to identify and pursue the most promising technologies within a broad spectrum of the science and engineering research communities and to develop those technologies into important, radically new military capabilities. Now, I want to remind you that this was back in 2003. Technical topic areas of interest to the Defense Science Office. This section describes the general technical interests of the Defense Science Office. However, the ultimate success of a proposal is based on the specific technical ideas advanced within these areas and especially the uniqueness of the proposed approach. Blah, 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 blah. So here they are. New materials, material concepts, material processing, and devices. Specific areas of interest include but are not limited to biomaterials, biomimetic materials, engineered materials, metamaterials, fracture phenomena and prognostics, femtosecond laser diodes, optical amplifiers, functional materials, ferroelectric, magnetic, etc. Interesting, huh? Material and concepts for advanced beyond silicon electronic materials and devices. It gets better. Materials and concepts for power generation, energy storage at all scales. Materials and structures for quantum information processing. Materials and structures for spin transport and control. That has to do with quantum networks, quantum entanglement, manipulating photons, sending the other paired photon away so that when you manipulate it, it is manipulated at distance. Multifunctional structure plus function materials, non-destructive evaluation, property life prediction, related technologies, novel approaches for material discovery, processing, or manufacturing and insertion, optical materials, self-healing, sensing, and adapting materials, smart materials, and structures, advanced mathematics, and problems of interest to the Department of Defense. Computational geometry and topology, dimensionality reduction, error propagation, uncertainty management, and database models, electromagnetic modeling and simulation, fast, scalable scientific computation, quantum information sciences, sensor management, signal and image processing, virtual materials development, processing, and evaluation. There's more in this document, but that is what is relevant to today's discussion. These were solicited by DARPA back in 2003, and we are rolling out to the public over the last year and a half approximately with any kind of fervor, this whole quantum thing. Oh, this patent from Verizon that relates to wireless quantum cryptographic key distribution. This was patented back in 2006. Ironically, it was filed on December 21st, 2006. Ironically. Something about that date just keeps popping up, doesn't it? So let's keep going. Argonne National Laboratory. So on August 26th, when the White House announced this and everybody started clucking their feathers and whatever else they did, everybody got all excited. That's where I got all this information that we're going to breeze through. They did this Twitter chat thing, right? 1980, Argonne physicist proposes a quantum mechanical model of the Turing machine back in 1980. Quantum mechanics. 81, Richard Feynman proposed a basic model for a quantum computer back in 1981. We are now in 2020. 1985, David Destouche describes the first universal quantum computer. That's 4 years later. The first universal quantum computer. 1994, Peter Shor develops an algorithm allowing quantum computers to factor large integers quickly 2020, Argonne and University of Chicago conducted real-world experiments in Chicago suburbs that achieves quantum entanglement across 52-mile fiber network. Today, the 26th, which is not really today, I'm just reading this, right? So August 26, 2020, White House announces $1 billion in awards for artificial intelligence and quantum information science. We might watch this video, we might not. It's more important to see this other video. I'm going to show you this real quick. For those interested, the quantum coin flipping game described in the TED Talk, they talk about a coin flipping game and how a quantum computer wins every time. Quantum strategies. There's a document here. You have to. It's behind a wall. I tried getting to it. I couldn't get to it. It talks about game theory, guys. Talks about game theory. We consider game theory from a perspective of quantum algorithms, strategies in classical game theory versus quantum game theory. So I ran a search, quantum game theory, and there's all kinds of cool stuff if you want to read about it. I pulled a couple documents so that you can kind of see quantum game theory, study of strategic behavior by agents with access to quantum technology. Broadly speaking, this technology can be employed in either of two ways, as part of a randomization device or as part of a communications protocol. We might spend time looking at this. It is incredibly dry reading. So it's not really something to read live. It needs to be, I need to read it a couple times and maybe do like 5 minutes on it. But I literally found this, I don't know, an hour and a half ago. Here's another one, an introduction to quantum game theory. Actually, it might be the same doc. It's not, it's a different one. This one was from University of Rochester. This other one is from Cornell. And this one deals with quantum game theory as it relates to economics, the finance system. So this strategy is kind of a universal strategy and is able to be applied in unique sectors. And I just found it interesting because it's kind of a buzzword for some of us, right? Quantum being one, and then game theory being another, this idea of game theory. We will continue breezing through these before we get to this video. That stick around. It's this guy Jordi Rose is interesting. So Q next generation quantum science and engineering. All of these I pulled from the Twitter sphere on the 26th to the 27th when all this was being announced. Research areas. What research areas will Q next focus on, and what big challenges is it looking to solve? Quantum information science, why is it important to the economy of the nation? Quantum information sciences use the principles of quantum mechanics to open up completely new ways to collect and process information. This will allow us to overcome many of the fundamental limitations of our traditional sensing and communication networks. Traditional sensing and communication networks, which are two of the focus areas in Q next. The implications of quantum information science on our economy and nation could be transformational. We are already seeing significant commercial interest arising from the promise of quantum systems to provide perfectly secure communications, novel solutions to highly complex optimization problems in finance and healthcare, more accurate measurements of physical phenomena, a far more realistic simulations of the real world. Interesting. So Q next. There's another piece on Q next here. And it's a collaboration involving the world's leading minds from national laboratories, universities, and private sector. It's one of the 5 national quantum information science research centers awarded by the Department of Energy in August of 2020. Led by Argonne National Lab, nearly 100 researchers from 3 Department of Energy national laboratories, 10 universities, and 10 leading U.S. quantum technology companies. This is a huge endeavor, folks. Huge endeavor. Headquarters, Argonne, just outside of Chicago. That's unfortunate. Partnerships. Look who the partners are. Argonne, you got Slack, Pacific Northwest National Laboratory, Caltech, Cornell, Northwestern University, Penn State, Stanford, UC Santa Barbara, University of Chicago, looks like Illinois State, maybe. University of Minnesota, Wisconsin, University of Wisconsin-Madison, Industry, Applied Materials, Boeing, Cold Quanta, General Atomics, HRL Laboratories. I've seen some interesting stuff from them, some of their patents, specifically as it relates to interacting with humans and antennas. But anyway, IBM, Intel, Keysight Technologies, Microsoft, and Quantum Opus. Opus, interesting. Huge endeavor, folks. Department of Energy selects Argonne to lead National Quantum Center. And here they are, all of the people. What else is in here? We're going to breeze through these because then we're going to get to this video where Jordi Rose, founder of Dwave, a Canadian-based company who is selling quantum computers to people like NASA and Google, talks about interdimensional communications using these quantum computers. So Slack and Stanford become founding partners of QNext, National Quantum Center. There's articles about their participation. Stanford's synchrotron radiation light source. Interesting, huh? Synchrotron? Not exactly a cyclotron. An instrument for ultra-fast electron diffraction, mega electron volt, UED, which is part of the LCLS, to study the properties of quantum materials which could drive the development of even better quantum devices. If we only knew what all this stuff really meant. Northwestern is a key partner in a $115 million national center to build revolutionary quantum computers. Fermilab-led directive, one of just 5 elite national quantum initiative centers funded by the Department of Energy, includes an interdisciplinary team of Northwestern faculty. Superconducting Quantum Materials and Systems Center, Superconducting Quantum Materials. Interdisciplinary expertise have been tapped all through this QNext at Argonne. Huge endeavor. They're addressing quantum coherence. That's where things have to stay in the same state, otherwise you destroy the information. Let's watch this video real quick.
SQMS stands for Superconducting Quantum Materials and Systems Center. Is one of the newly awarded centers under the Department of Energy National Quantum Initiative. Fermilab, together with its partners, has a primary goal to build a revolutionary quantum computer here at Fermilab, and to also develop and build new types of quantum sensors that will allow us to look for elusive particles. In particular, we may be able to prove or disprove the existence of dark matter. One of the main problems that is at the heart of the SQMS Center is quantum coherence, which means being able to preserve quantum states, which are very fragile, for as long as possible. The key to the advancement of the field of quantum computing and quantum sensing, improving the lifetime of quantum states, how long a quantum state that I create in a device can actually live. So what we have behind here is superconducting devices that have demonstrated world record of seconds of coherence of quantum states, which is orders of magnitude above the state of the art. What does this mean practically? This means that we can push what we can achieve in quantum computing, because going from milliseconds or below to seconds will allow us to perform complex and useful quantum computations. And in quantum sensing, if I'm looking for an elusive particle that is around us, I can't see it, but I want to detect it, the fact that the quantum states live long enough in these cavities will allow me to catch that particle and be able to detect it. Fermilab is collaborating for the SQMS Center with several institutions ranging from academia, national labs, and industry, nationally and internationally. In particular, we have some core partners, which are Rigetti Computing, Northwestern University, Ames National Lab, and NASA Ames. And we have several contributing partners like national and international universities and several industry partners such as Goldman Sachs or Lockheed Martin. SQMS brings together more than 80 world-class experts in all the disciplines that are needed for the advancements for making new breakthroughs in quantum information science. In particular, we bring together top world experts in superconductivity, in material science, in superconducting quantum devices, in particle physics, in computational science, in cryogenics. All the science and technology that is really needed to achieve our goal of building a revolutionary quantum computer and to develop and build the new quantum sensors that will allow us to discover new particles. So Fermilab is the premier US particle physics laboratory. Our mission is to understand the world around us at its most fundamental level. We, as Fermilab, have developed unique technologies, such as what stands behind my shoulders, which is superconducting RF particle accelerators, which now will become unique building blocks for quantum computers and quantum sensors. Fermilab is the place that hosted the Tevatron, which was for many years the highest energy particle accelerator in the world, that really brought together for decades many thousands of collaborators from around the world and enabled new physics discoveries. We discovered many new particles. It's with the same spirit of hosting large collaborations and unique experiments. So it's in a spirit of collaboration and ambition that we go into hosting this superconducting quantum materials and system center.
So they have a particle collider there, folks, just like CERN. And I noticed that they talked about superconducting RF technologies as it relates to quantum sensing. So there's a lot going on there. There's a lot in that video, but let's keep moving forward. I do want to get to Jordi Rose. Brookhaven, another national lab to lead Quantum Research Center. And it's all of these are good reads. Some of the information is somewhat redundant, but they're all good reads. And if anything, it's just to understand and familiarize yourself with these institutions. I mean, Brookhaven, just one. Some of the stuff that they post on Twitter, for example, I mean, it's freaking amazing what these people do. These national laboratories are where our public technology, military technology too, I'm sure, this is where it comes from. And when they start rolling out, oh, we can do this with this piece of equipment, or we've invented this idea, or we've proven this theory or whatever, it comes from these national labs. And you can start putting all the pieces together, so to speak, if you look at their publications long enough. It's just what they tell you they can do is it's always presented in a very basic, rudimentary fashion. Like, oh, we've made this super complex, super expensive, bulky thing, and it's proven this. And this is to that point with quantum computing and AI and our ability to basically print and create things on demand down at the atomic level at this point. Once it's made in a lab, I would assume it would take a very minimal amount of time to miniaturize it and put it into something that's mobile, a workable type of device, whatever its application is. So that's the way I try to view the things that the publications that come out of these types of schools and labs, is just understanding that just because it looks bulky and it's at some major exploded scale, so to speak, a large scale where it's not going to be practical as it relates to being used, it's not going to take long to scale these things down and tweak some of the characteristics or parameters to make them room stable, environmentally stable, and then mobile and functional outside of the laboratory environment. Princeton involved in quantum science initiative. We've got Stony Brook University, Quantum Information Science Research Center to be established, Brookhaven National Labs. So they're partnering. The founding of the Co-Design Center for Quantum Advantage establishes Stony Brook University as one of the nation's leading centers in quantum information, a strategically important and highly competitive area of research worldwide. This is where we're going, folks. We are going into the quantum world. Another one, Berkeley. Everybody's heard of Berkeley. 115 million quantum system accelerator to pioneer quantum technologies for discovery science. Berkeley. They also have particle accelerator. Let's watch their video.
I'm Irfan Siddiqui, Director of the Quantum Systems Accelerator, or QSA, and a faculty scientist at Berkeley Lab. My own research revolves around the use of superconducting circuits to build next-generation quantum computers. The Quantum Systems Accelerator brings together all the science pieces to tackle the most critical and timely of questions. How do we make the best use of the state-of-the-art in quantum hardware? What problems are such machines most adept at solving? And what is the path forward to more powerful quantum machines? Our approach assembles a suite of cutting-edge quantum hardware, including atoms and superconductors, along with the theory team to prove the advantage of quantum systems in solving urgent science problems that are beyond the reach of today's computers. Interwoven within this structure are deep relationships with state governments, work boards, and community colleges to grow the workforce and industries of the future. Success will ultimately involve bringing the benefits of quantum technologies to society at large. A key step will be building specialized quantum prototypes targeting transformational advances in new materials, pharmaceuticals, and our understanding of the physics of the universe, as well as other exciting applications. In this journey, we will assemble students, career scientists, and engineers into a welcoming, diverse, nurturing, and sustainable environment to fuel progress over the next decade. Our team looks forward to playing a leading role in pushing quantum to the next frontier.
Yeah. So if I were young again, this is where I would want to go personally, is to engage in this whole idea of quantum. What's going to happen, in my view, is in another 5 to 10 years, whatever's learned is going to ultimately be built into software where it's going to be plug and play. And so people that don't necessarily have all of the math and the science background are going to be able to interact with these quantum systems once the software architecture is built around the discoveries that are going to be had over the next 5 to 10 years through these types of initiatives that are receiving funding to the tune of $2 billion. So once that happens, I can see these technologies being available online, so to speak, to anyone. Hopefully they're going to have some type of restraints. But at some point, research is just going to be automated. AI will research and provide us with information. We have to be careful, I think, as a species to not get lazy once we build enough intelligence into AI. Fermilab, National Quantum Information Science Research Center to build revolutionary quantum computer. Northwestern, Rigetti, Ames Laboratory, NASA, all partnering together. So and then there's a thread here on Pacific Northwestern Laboratory. They'll be participating as well. Let's listen to Jordi Rose. We have to do this in chunks. So the link for the whole video, if you want to watch uninterrupted, is in the show notes. If you're not on YouTube, then PATRIOTSoapbox.com. Go to the Big Tech show page and look for episode 74 underneath the section Read, Watch, Think for Yourself. There's archive notes there. Here we go.
Consider this next group of speakers somewhat unusual, if not to say strange. We have the creator of what is the world's first quantum computer in person here from Burnaby, BC. We have the president of the super high-tech company that makes Canada's iconic Canada Arm, but whose hobby it is to try and reconcile modern science with the Bible. And we have...
That sounds like an interesting day of speakership, right? We're going to listen to Jordi. He's I think first up. This is a 20-minute video.
I have a filmmaker from Los Angeles who has stumbled on what appears to be evidence of life after death. And my thought in putting together this somewhat improbable combination of speakers was that out there where the theory of the very large and the very small connect, and out there where our 13.7 billion year old and expanding universe touches the void, you come upon mystery and the possibility of God. That was my thinking. So let's begin with Jordi. Jordi, I don't understand much about quantum computing except that it's supposed to be the next big thing in power and in speed, and that you are the only company in the world now actually making one.
Well, so this was put online, or at least posted to this channel, August 25th of 2015. So we're quite literally 5 years ago it was put on this channel. I don't know exactly when this was had, but Jordi Rose, founder of Dwave, recent clients are Google and NASA. They believe the power of quantum computing is that we can exploit parallel universes to solve problems that we have no other means of confirming. That's in quotes, exploit parallel universes. Simply put, quantum computers can think exponentially faster and simultaneously such that as they mature, they will outpace us.
Hopefully after this 17 minutes, you'll understand what they are and be excited about what you might be able to use them for.
These are really big deals. They come in at about $15 or $20 million a piece.
Something like that.
And have been bought by major American research and corporations.
That's right, correct.
All right, Jordi.
Thank you. Bye, everybody. So quantum computing is a very technical subject, and I'm not going to talk a lot about the specific details, of which I'm glad, sure you're glad. But I'm going to try to give you an idea about what the kind of thing is that we build and why people are so excited about it. But I'm going to wrap that story in another story. How many...
All right, so the next minute or so is him talking about this bear that he buys for his kid, and this discussion he has with his kid about the bear. His kid's scared, doesn't want to go to sleep in his room, right? And Jordi basically says, well, you have this bear. And the kid says, well, he's not alive. And so he goes in and he goes through this story about his kid trying to define how people understand or conceptualize what is alive.
Each of my children has fixated on a particular stuffed animal as being their special friend or toy. And in particular, my middle son, James, absolutely loves this little guy called Bear Bear, which is the picture that I'm showing up here. Bear Bear was a limited release tie Beanie Baby, and there aren't very many of them that were made of his particular form. And one Christmas, others that were for sale, and I bought both of them. So now he had last week. He wanted to sleep with his older brother in his bedroom, and his older brother wouldn't let him. And he was very sad and despondent, and he was like, I'm scared, I don't want to sleep by myself. And I said, well, you've got Bear Bear. And he said to me, Bear Bear isn't real. And so I found this very intensely distressing for a variety of reasons that maybe you'll understand when I go through this. And I assured him that Bear Bear was as real as anything else in the world. And he said, but he can't speak and he can't move.
So it's kind of important to hear this, only because I think what he's trying to illustrate, or at least present to the audience, is how do you define something that is alive? What is alive?
And so I said, well, what you really mean is he's not alive. And he said, yes, that's what I mean. So for very young children, the sense of being real and the sense of being alive are somehow connected. And I'm going to circle back to this point at the end. But before I do that, I'm going to tell you a little bit about quantum computers and why people care so much about them. There are literally tens of thousands of some of the brightest people in the world today trying to build these machines and understand them. And I'm going to tell you why. In my last 15 years of working on this type of stuff, I found that scientists divide up into two categories of zealots about this field. The first half are people who are absolutely entranced by the physics of these things. This quote is from a respectable scientist, in fact, one of the founders of this field, that may look a little strange to you who don't follow theoretical physics, but there is a very clear prediction that our most successful theory of nature makes, and that is
quantum computation will be the first technology that allows useful tasks to be performed in collaboration between parallel universes. And this was stated by David Destouche, one of these scientists that he's talking about, back in 2005. Back in 2005, which was approximately 10 years before this was recorded.
Is that there are an enormous number, mind-bogglingly large number, of parallel realities, as real as this one, that have different consistent histories. So imagine a world where all of the laws of physics as we know them are obeyed, but different decisions were made along the way. Different decisions at the level of tiny microscopic particles, different decisions all the way up to what you chose to eat for lunch, and whether you chose to come to this session or not. Quantum mechanics makes a very specific prediction that all of those are as real as the thing that you remember. And this is bizarre, because we don't see those other things. But science has reached the point now where we can build machines that exploit those other worlds. And quantum computers are perhaps the most exciting of all of these that we have within, or almost within, our grasp right now. So people...
Yeah, so it's kind of hard to get your mind wrapped around, no pun intended, that every decision that you make, every chirp of a bird, every leaf that falls, every gust of wind, any thought you have, that's all something that's quantifiable. It's all something that happened or happens or will happen. And what this guy is saying is that any one of those individually or any number of those things collectively are occurring simultaneously and occurring in a different order and or in a different way, simultaneously, in other dimensions. That's how he's trying to quantify what the other dimensions kind of means. And it's this idea of probability. What is likely to happen versus what is unlikely to happen. And then once it happens, there it is. So it's an interesting idea, but when you apply quantum mechanical theory to it, that's really what he's getting at, is that something is nothing and something is everything at the same time until it is looked at, until it is observed. And at that moment, then it becomes something what we would consider finite or quantifiable or measurable. The measurement itself can influence it. And so what he's getting at is these computers can go in and look at many different probabilities, many different scenarios, many different outcomes simultaneously, and be able to draw information and inferences from that, and then apply it into our world. That's what he's getting at.
People from a physics background love this. They want to understand the world. They want to understand the universe, how it all works. There's another type of person who tends to come from the computer science side that's like, yeah, okay, that's all great. But there's a different thing going on here, which is just as exciting, if not more, and that these machines that supposedly can do this wild stuff, let's forget about how they work, if you could build one, could solve problems that you could never, ever solve with any computer of the sort that we built. If you took every single atom of silicon in the world and made the most sophisticated conventional Intel-style processor that you could build, there are problems we know of that I could write down on a sheet of paper that you could never, ever, ever solve with that thing, that you could with this kind of machine. So that's very exciting. Humans use tools to do things. If you give humans a new kind of tool that can do things that you couldn't otherwise do, imagine the possibilities.
And that's really where this is going, is this idea of being able to run, for lack of a better term, a theoretical infinite number. You can run a theoretical infinite number of scenarios or an infinite number of simulations in a quantum computer or a quantum network, whereby you have a cloud that has many quantum computers connected together, all sharing resources, an infinite number of simulations to reach some conclusion or draw some introspection or some insight. And it may not be a single answer. It may be a many different answers. This is where software and programming and AI comes in. The quantum computer is simply a mechanical piece of a larger equation.
So you may think, well, this is all fine and dandy, but aren't these things in the realm of theory and speculation, kind of in the same regime as other futuristic things you may have heard of, which may be allowed by the laws of physics but aren't here yet? That's not true. There are, in fact, many of these machines deployed now in openly available research centers following the model that was used to introduce supercomputers to the world. They're too big and ornery and difficult to operate to put in your home, too expensive also, but you can give them to a place which will manage them as a shared resource that will offer that service to the world. And there are two of these now. One of them is at the University of Southern California. And this analogy with flight, I think, is an interesting
University, Southern California, Lockheed Martin, Quantum Computing Center. It says in that, on the slide in the back there, it's a game changer for humanity. Computationally, this is the equivalent of the Wright brothers at Kitty Hawk. And they're standing next to a D-Wave computer. And this is D-Wave's website. It's D-Wave sys.com, and this is pretty interesting website to go look at. Canada and Silicon Valley is where they're at. So what they're advertising here is a 2000 Q. They've actually gone up to a 5 at this point, but this is a D-Wave computer, quantum computer. More on this during our intermissions.
One. So a horse can beat, or could beat, the initial flight of the Wright brothers flight in speed. But a plane is not a faster horse. A plane is a different kind of machine. The plane takes advantage of another resource that nature gives us, this third dimension, in order to do something that matters to people better that you could do with any horse. It doesn't matter how fast you make a horse, it will never fly, at least the kinds of horses that we know about. So these types of computers now are being thought of in the same way. They're not terrifically powerful yet, but they're doing something completely different than what your computer does. And that thing is like flight. It gives these computers access to these new resources, maybe you could call them parallel universes, in order to do something that you couldn't otherwise do. And that's not the only one. In fact, the one I'm going to come back to and talk to in the context of the story that I'm wrapping this in was recently installed at NASA.
Google and NASA launch Quantum Computing AI Lab, MIT Technology Review. This is the slide in the background. And that looks like May of 2008, 2009, something like that, if I'm looking at that correctly. It's kind of blurry. Maybe it's got a 10, like a 1 there, and I don't know. Quantum Artificial Intelligence Lab will use the most advanced commercially available quantum computer, the Dwave 2. That is, NASA was being scaled down. We all kind of know what's going on with Google, right? They're not necessarily beholden to any country at this point. They are their own monolithic structure. In my view, a cancer from the Department of Defense and DARPA and the intel agencies. Hopefully it can be cleaned out. But it is the AI supreme company at this point. Google basically takes the cake at this point. So here we go.
And Google was the primary interested party that pulled this whole thing together. And this one is really exciting to me, because what they're going to do is apply this machine to an area that I think is fundamentally important. It's the crux of our future as humans.
So it says May 16th, 2013, just to clarify. So we're eight plus years ago.
And that's, can we build machines like us? So building machines like us might be possible. I certainly believe it is. I might be wrong. But what I do know is that the types of approaches that people are taking now to build intelligent machines benefit immensely from what this machine that we've built does best.
This guy just said that Google, partnering with NASA, wants to build machines like us, meaning like humans. Robots that have the same ability to interact with the environment, our environment, but with computational capacities that exceed the human brain. So they can do things that we do, anything that we do better. And he says that in another talk that he gives that we will likely watch on Sunday/Monday.
So what this center is about is applying this beautiful new computational idea in the service of trying to make intelligent machines. Now, I can't think of anything personally any cooler than trying to use quantum computers to build intelligent machines, so this is very exciting to me. Steve Jurvetson has been a longtime friend and investor in the company, and for those of you who don't know him, he's a Silicon Valley investor who's probably the smartest VC that I know of, and certainly the one that's the most attuned to technological trends. He's on the board of SpaceX, Tesla, Synthetic Genomics, which is Craig Venter's company, is trying to build artificial life, and Dwave, and that's it. And this is his particularly poetic way of framing the difference between the machines we build and conventional computers. This is what they look like. There are two of them. These are from our lab in Burnaby in British Columbia.
What is upcoming is shocking. The statements he makes are remarkable, but we're gonna pause for a minute and just kind of look at, this is a D-Wave computer, right? So that's what was on the back of that slide. And what's inside is similar to the kind of the pictures that we were looking at from these national laboratories. And D-Wave touts to being, one of the first one to make them commercially available. This is a qubit chip, a D-Wave chip. Looks like a computer chip. That is the centerpiece of a quantum computer, and it's down basically at the bottom. And look at that. I mean, they're beautiful machines, to be honest with you. They're 2000 tiny superconducting devices known as qubits are chilled close to absolute zero to harness quantum effects. The user models a problem into a search for the lowest energy point in a vast landscape. The processor considers all the possibilities simultaneously to determine the lowest energy and the values that produce it. Multiple solutions are returned to the user's scale to show optimal answers. So this is a probability computational machine. Here we go.
From the outside, they look like giant black monoliths, big metal boxes, about 10 feet on a side, 12 feet tall. And they are powered, they have a fridge inside them, a refrigerator that cools these chips to almost absolute zero. Just a wisp, a fraction of a degree above absolute zero. Hundreds of times colder than interstellar space. Amongst the coldest and most isolated and extreme conditions that humans have ever been able to engineer. These fridges, interestingly enough, which are called pulse tube dilution refrigerators, have a thing called a pulse tube, which emits a sound roughly once per second, which sounds eerily like a heartbeat. So if you have the opportunity to stand next to one of these machines, it is an awe-inspiring thing, at least for me. It feels like an altar to an alien god.
Should we back that up just a little bit? Let's back that up just a little bit.
At least for me. It feels like an altar to an alien god.
Should we, one more time? Just one more time. Humor me.
At least for me. It feels like an altar to an alien god. They really are impressive machines. At the heart of this big box is a tiny chip about the size of your thumbnail. And on this chip resides all of the wonder and magic that makes this thing go. I'm not going to describe in any mathematical detail how it all works, but let me give you an analogy. In quantum mechanics, there's this concept that a thing can exist in two states which are mutually exclusive at the same time, quote unquote. And I'm using those words because the English language was developed before we had concepts to describe what these things actually are doing. But I'm going to give you a roundabout way of understanding this. Imagine that there really are parallel universes out there, and now imagine you have two that are exactly identical in every respect, all the way out to the horizon as far as we can see, down to the last little atomic detail of every single thing, with only one difference. And that's the value of a little thing called a qubit on this chip, which is a contraction.
So what he's getting at is he's trying, this is like the egocentrism of this guy is crazy. What he's saying is that the chips that he's building becomes basically like a gateway whereby multiple dimensions overlap. And at that point on the chips that he's talking about, the chips that are in the computers that his company makes, will be able to determine the outcome in this reality compared to another dimension. Just try to get your mind wrapped around this. I mean, when people used to think that, some place in Europe was the center of the universe, and then at some point that the Earth was the center of the universe, this dude's now saying that the computer chips that he's building, imagine for a moment, everything's the same down to the smallest atomic level, except until you get to the qubit on the chip that I built. And I can then dictate the outcome of reality as it relates to other parallel dimensions. Anyway, I'm digressing. Let's continue.
Of quantum bit. And that qubit is very much like a bit or a transistor in a conventional computer. It has two distinct physical states, which we call 0 and 1 for bit. In a conventional computer, these are mutually exclusive. That device is either one or the other, and never anything else. In a quantum computer, that device can be in this strange situation where these two parallel universes have a nexus, a point in space where they overlap. And when you increase the number of these devices, every time you add one of these qubits, you double the number of these parallel universes that you have access to, until such time when you get to a chip like this, which is about 500 of these bits, you have something like 2 to the 500th power of these guys living in that chip.
He said 2 to the 500th power of these guys living in that chip. It's like standing next to an altar of an AI god. And what they're selling now, at least according to their website, is the D-Wave 2000 qubits. 2 to the 500th power. How many parallel dimensions is that? Okay, so you can see this. Yeah, you can see this. 3.273 times 10 to the 150th. That's how many parallel universes this guy is basically talking about in this talk, and he's selling 2 to the 2000th power. This calculator says infinity. Isn't that something? So anyway, the point is that according to this guy, there is the nexus on his little qubits that tie parallel dimensions together, of which we're able to draw information in and out of or interact with. And he's in his talk saying they had 2 to the 500th power, computational power qubits, right? So 500 qubits on a chip, which was 3.2 and change times 10 to the 150th power. So think of it as 3 with 150 zeros after it. Just to round, 3 with 150 zeros after it. That's how many quote unquote parallel dimensions. And he said that there are little guys living on this chip. Let's go back just a touch.
There's about 500 of these bits. You have something like 2 to the 500th power of these guys living in that chip. So the way I think about it is that the shadows of these parallel worlds overlap with ours. And if we're smart enough, we can dive into them and grab their resources and pull them back into ours to make an effect in our world. Now, this may sound very odd to you and bizarre, and in fact, I am using language that a normal theoretical physicist probably wouldn't use, but this is, what I'm telling you is absolutely correct and in line with the way that these things actually work. We've been doing this for some time now, and in fact, we have our own version of Moore's Law. The doubling of the number of these qubits on the chip has happened once a year for the past 9 years.
At what point are they going to be able to run quantum simulations whereby everybody is mapped, all of your cells are mapped and networked, and they have computational chips that are able to have a point-to-point quantum entanglement with each and every cell in your body? Anyway, that's kind of a even crazier thought to have for a moment there, but let's continue.
Last 9 years, every year, the number of these qubit devices has doubled, and it will continue to do so. As a point of reference, in terms of how fast these things are, in one generation of chip, the one from the system that was installed at USC to the one that Google and NASA have now, the speed of the device went up by almost 500,000. This is the kind of progress that you're going to see with these types of machines going forward. And 500,000 sounds like an abstract number, but I put up a little mental comparison here to see what 5,000 really means. 500,000 is a big number when it comes to speed. All right, so now I'm getting into the last part of my talk where I'm going to make some predictions, some dangerous predictions. So predictions are very dangerous for a variety of reasons. Often they're wrong, which is one. But I think they're important because predictions somehow are our internal desires made manifest. Predictions.
This whole idea conceptually of tapping into the quantum field, 0-point field, basically. And we're able to get extra information. We put in a certain amount of energy and we get more than what we put in back out. Information. Whatever that means to you, what does information mean to you? And then how do you translate that into our world? My issue with this is if we're building these things, can they talk back? Is it a one-way mirror? Is it a one-way portal? Or is it a two-way portal? Or a multi-dimensional portal where, because we built this thing, we're like tying into the quantum field, and is that a passive field? Is that just something that's like a lake or a pond, and we can just kind of just scoop out some information and walk away? Or what's really going on with that? What does interdimensionalism look like, and what does interdimensional communication look like? And if we consider for a moment that not everything is made of matter, and that when we go back to this idea of what is alive, what does alive mean? Does it have to be breathing? Does it have to be made of carbon? Does it have to drink water, and does it have to poop and pee and all the things that we understand is what is alive? Does it have to be those things? Is there, or are there, other intelligence out there that don't exist in the same capacity that we do? Anyway, here we go.
Predictions are about what we want to happen, maybe not what will happen. And I'm going to make 3 predictions, and all of them are dangerous in the sense that they're very unlikely to happen, maybe, but I think that there's a very good chance that they may. As an aside, I just wanted to say that at least in the Valley, Silicon Valley, and maybe in the United States in general, there's a very deep feeling of unease about the way technology has been developing. because we have all of these vast array of very smart people, and what they're doing is crap. They're building things that cannot last. They're building things that are not important. This is a little bit of a controversial point of view, but I believe it.
So there's his sales pitch in my view. I to some extent agree with what he's saying, but I also heavily disagree. What he's either not seeing, acknowledging, or admitting is that the things the Silicon Valley are building are the various pieces required to ultimately enable this quantum network, this quantum computation, this interdimensional access to be deployed globally. With the implementation of directed energy systems that can be controlled and modulated and interfaced at a level of precision that enables quantum information to be exchanged from point A to point B. Hence the patent I showed you earlier with the satellite. It's one example. One example. That's what I think is happening. They're basically simultaneously constructing many of the facets needed to roll out a quantum network whereby when these systems go online and they're networked, we are literally opening up entirely new paradigms in every facet of our lives. Potentially opening up spiritual dimensions. Potentially opening up spiritual dimensions. What does I'm hesitant to even say it. What does a beast system look like? What does opening the gates of hell look like? How do you create stable gateways that potentially allow information through? What does it mean to be alive? Does it have to be breathing to have intelligence? I don't know. These are just the questions that arise in my mind when I listen to this guy and I listen to other highly informed people provide their analysis about quantum computing and how it relates to prophecy. Let's just say that.
But I think that the reason for this is it's low-hanging fruit. Computers haven't been around for a long time. And I think that what's going to happen is that as people get more comfortable with computers, the attention will turn from the Twitters and the Facebooks to very important things.
So the Twitters and the Facebooks have built the networks and have built the sensor arrays and have built the requirements for cloud computation to be in constant contact and communication with your device, requiring real-time network connectivity and all of the background components required to handle and manage stable connections, to provide updates and notifications and everything it needs to do to collect information about you in real time. That infrastructure has been built and created with the rollout and implementation of the networks that he's claiming are a waste of time and disposable as it relates to Silicon Valley's endeavor. And that's where I disagree with this guy, is that those were built purposefully in order to build out a network whereby sensors and antennas and other methods to deliver energy in a known, repeatable, very specific way have now been placed throughout our environment. They are now saturating our environment. We are living amongst the architecture that has been constructed that will be transformed and integrated onto these quantum networks.
So here's my first prediction. I'm going to predict that by 5 years, NASA will have found an Earth-like planet with Earth-like atmosphere and water on it, and serious people will start discussing how we get there. And by the way, they're going to use one of our machines to help do this. So that's my first prediction. My second prediction is that this business of parallel universes is going to turn out to be very important. This picture that I've got under here is what's called a gravitational lens. When Einstein proposed his general theory of relativity, it came with a bunch of experiments that you could use to test it. And one of them was that if there was a point of light very far away and a galaxy in the middle, that galaxy should bend the light and you should see a ring.
So what this prediction says is by 2023, a major breakthrough in physics will occur based on a model whose cornerstone is the reality of parallel universes. An experiment will be performed on a quantum computer that will support the new theory. And then he's using this analogy of Einstein's theory of light at a distance, basically creating a circle around it, a crown, a halo.
And this was eventually observed. And I think what's going to happen is somebody is going to come up with an experiment to test this reality of these things. And we're going to be able to do so. My third prediction that I'm going to end on is the most important of all. I believe that humanity is on the cusp of the most important technological, societal revolution that's ever occurred. And that's when we got to the point where the machines that we build outpace us in every respect.
That's crazy. That we are going to build machines that will be able to build and upgrade themselves. And we are going to put something equivalent to intelligence in them. And if we're building networks that ultimately provide access to the quantum field, that 0-point field, what exactly are we doing? And what are we to become?
I don't mean that they're better calculators. I don't mean that they're better at searching. I mean everything. And I think that we're very close. And my prediction is that within 15 years, we will have machines that outpace humans in everything. Thank you very much.
So if you can't get your head wrapped around this idea of a parallel universe, oh, fine, you could throw that away. Look up, type in, I'll show you. Let's do quantum. Let's see what happens when you type in quantum and probability. Stanford Encyclopedia of Philosophy, quantum logic and probability theory. Mathematically, quantum mechanics can be regarded as a non-classical probability calculus resting upon a non-classical propositional logic. More specifically, in quantum mechanics, each probability-bearing proposition of the form, quote, the value of a physical quantity, A, lies in the range B, is represented by a projection operator on a Hilbert space H. So, good, to kind of break it down here. What are we to make of this? Some have argued that the empirical success of quantum mechanics calls for a revolution in logic itself. This view is associated with the demand for realistic interpretation of quantum mechanics, one not grounded in any primitive notion of measurement. Against this, there is a long tradition of interpreting quantum mechanics operationally, that is, as being precisely a theory of measurement. On this latter view, it is not surprising that a logic of measurement outcomes is a setting where not all measurements are compatible, should prove not to be Boolean. Okay, so really what this is saying is, if you don't believe that there are parallel universes, do you believe that there is a law of probability? And what I mean by that is, if you're lost driving down the road and you come to a fork in the road, how likely are you to go to the left or to the right? And if you have someone next to you in the car who says you should go right, are you more inclined to go right versus left? What if you see signs on the road? What if you're hungry and you're running out of gas? The sign on the left says food here. The sign that goes to the right says gas here. What do you do? The idea is this concept of probability. And so if you want to take the esoteric nature out of it, if you want to take the spiritual nature out of it, and this idea of intelligence beyond the human, beyond the physical, this idea that angels and demons don't exist. You want to pull that out and look at it as agnostically, as non-spiritually as possible. Look at it simply as this idea of probability. And this idea that anything is possible until something happens, until a decision is made, until an action is taken. And this idea that we are building computers that are able to run an infinite number of combinations of simulations to project what the probability is of decisions that are going to be made, that are going to be made, based on what has happened and what is likely to happen, based on current events. The more sensors you have out there drawing in information, the more accurate your predictions, the more likely you are to be able to make intelligent decisions about things that have not happened yet. This idea of future predicting technology based on the aggregate information you're able to receive at this time and smashing it against historical data, empirical data, to then draw a hypothesis on what it is that will happen. I don't know how else to say that other than I believe that there are angels and demons, and I am inclined to believe that this guy is trying to put in layman's terms what physicists and scientists have ultimately discovered. And that is, there is something measurable out there that does not exist in our plane that we are now able to interact with, communicate with. And when you smash that up against this whole plethora of knowledge and history that through many cultures discusses interacting or interfacing with the spirit world through various mechanisms, chanting, dancing, hallucinations, taking hallucinogenics, drugs, sacrifice, drinking blood, you name it. And they're interfacing with other entities that they're ultimately either worshiping or extracting or getting information from. What's the freaking difference? Other than at this point, science has gotten to a point where we can measure and potentially interact with these dimensions, these entities, this information field. If you want to take the human component out of it, the emotional aspect out of it that we associate with an angel or a demon or an entity, we're putting some humanizing characteristic, some emotional characteristic around it. Take that away. If you are interacting with a information field that is responsive to what it is you're doing with it, asking it, whatever, if we have been able to build systems that can do that without taking a hallucinogenic, without having a near-death experience, without having to drink some blood, without having to sacrifice somebody or something, without having to dance around and chant, without having to be at a certain place on the earth at a certain time, going through some certain ritual. If we've been able to create systems that allow us to interact on demand with this information field, does it interact back? Is it friendly? Do you want to defend against it? Do you want to know if it's even hostile? I do. It's like anything else. Are you going to go out if you're a caveman? You don't have a firearm. All you have is fire and a spear. How inclined are you to leave the comfort of your fire and just go walking around in the dark when there's lions, tigers, and bears, oh my, everywhere? Are you going to do that? Do you think the humans that survived, that ultimately procreated to make you, do you think they did that? I don't. I think they made sure that they had every provision that they could to ensure their survival. And that's what I think is really going on. Is what is America, because I'm from America, what is America doing to ensure its survival as it relates to the new battle space that is being shaped, or in my view is already here? What are we doing about that? What does preservation of self look like? What does preservation of liberty look like? What does preservation of sovereignty look like? Do you think another country is going to even attempt to embody those things if we are dealing now with this idea of accessing an information field that is going to provide an asymmetrical advantage to anything we do in the third dimension? Is any country going to give those types of considerations? And if they are going to provide or give those types of considerations, are they going to do it in a manner that is similar to, better than what America and or Western civilization, for that matter, is going to offer?